Here we're given a function g, and we're told that x is positive and x is not equal to k, where k is a constant. And we're asked to find the value of k, or deduce the value of k. The only thing we know about k is that x cannot be equal to k. So what's the value of x that's not allowed? So if we think of the domain of this function, what is it that x can't be? Well, x can't be 0, and it can't be negative because you've got the log, and we're told x is greater than 0. But because it's a fraction, the denominator cannot be equal to 0. So we can say that ln x minus 2 cannot be equal to 0. So whatever x is that makes it equal to 0, that's k. So basically, log x cannot be equal to 2. So x cannot be equal to e to the power 2. That's how you invert the log. So e to the power 2, e squared. So it means that k almost certainly is e squared. So we've deduced that k is equal to e squared. That's the value of x that isn't allowed. The question goes on to say, prove that the derivative of x is greater than 0 for all values of x in the domain. So we now need to differentiate g of x. So it's a quotient, so clearly we're going to have to use the quotient rule. So the numerator is going to be our u, so u is 3 ln x minus 7, and our denominator will be v, ln x minus 2. And if you differentiate the numerator, the derivative of log or ln is 1 over x, so that's 3 over x. And v dash will be 1 over x. Now, if we remember the quotient rule, that's g dash is simply u dash v minus v dash u divided by v squared. So if we just substitute the expressions we have for u dash, v, and v dash, let's start with the denominator, v squared. So that's ln x minus 2 squared. Numerator is u dash, that's 3 over x, multiplied by v, which is ln x minus 2, minus v dash u. So that's 1 over x times 3 ln x minus 7. So we're trying to show that this is positive. So I'm going to try to simplify it. So if you look at the numerator, you've got 1 over x there, and you've got 3 over x there. We can probably take 1 over x as a common factor. So that's 1 over x in the numerator. And then you're going to have 3. So that's 3 times ln x minus 2. So that's times 3 ln x minus 6. So all I did was multiply the 3 by both of those terms, minus 3 ln x minus 7. And again, if you multiply minus 1 times both of those, it should simplify. So ln x minus 2 squared. So that looks like it's, if we bring the x to the denominator, x ln x minus 2 squared, you've got 3 ln x minus 6 minus 3 ln x plus 7. So that will cancel with that, and you'll have 7 minus 6 is 1. So you end up with 1 over x ln x minus 2 squared. Now, we're not asked to solve this. All we need to do is to show that this is positive. All we need to do is show that the derivative is positive. Now, we know that x is positive because we're told in the question. So that is greater than 0. And we know that this is never equal to 0 because we said x is never equal to e squared. And when you square something that's non-zero, you're going to end up with something positive. So that's always going to be positive. So if you have a fraction where the denominator is positive, then you can be sure that the quotient is positive. So you can say, therefore, g dash of x is greater than 0 for the given domain. Because, if the domain was different, it might not be the case. But actually, I don't see how that could be the case, because we're told that x is positive, and it wouldn't have been possible for x to be negative because you can't take a log of a negative number. So I think that's all we need for this part of the question. The question goes on to ask to find the range of values of a for which the function is positive. So not the gradient this time. They're not asking about the gradient. They're asking about the function itself. So this is the function, g of x. When is it positive? Well, I think it's positive when the numerator and denominator are both positive, or when the numerator and the denominator are both negative. So the numerator and denominator really have to have the same sign, or their product should be positive. So the numerator and denominator should have the same sign, either both positive or both negative. Only that way will g of x be positive. So if they have the same sign, then their product is going to be equal to 1. Or their product is going to be equal to something positive, right? So if you multiply a positive times a positive, that will give you a positive. So negative times a negative, that will give you a positive. So I'm going to say that the product of the numerator and denominator has to be greater than 0, because that might give me an inequality that I can solve. So I'll say 3 ln x minus 7 times ln x minus 2 is greater than 0. That sort of looks like a quadratic if you were to replace that with some other variable. So if we were to say something like 3w minus 7 times w minus 2 is greater than 0, then you would probably see that as an upward opening parabola with roots at w equals 2 and w equals 7/3. So here you've got 2 and here you've got 7/3. And because we want the parabola to be positive, then that will be these upward parts of the parabola. So x, or w in this case, would have to be less than 2 or w greater than 7/3. And if we replace w with ln x, then we're going to have ln x less than 2 or ln x greater than 7/3. And we can get rid of the log by saying x less than e squared or x greater than e to the power 7/3. And I guess that's what they want. They're asking for the range of values of a for which g of a is positive. So you'd say something like a is an element of a set of real numbers. A is greater than 0. A less than e squared or a greater than e to the 7/3. So that's how I would phrase the answer. And I think that will be your final answer.